Hello everyone, welcome back. Let me start with a curious thought. Have you ever placed one coin exactly on top of another from the same mint year? They cover each other perfectly, right? That's the magic of congruence. Congruent figures are those that are equal in all respects, both shape and size. If one figure can completely cover another without any gap or overlap, then they are congruent. Think of photographs of the same size, two ATM cards from the same bank, or even two bangles of identical size. They all match perfectly. Another neat example, if we draw two circles with the same radius and place one on the other, they completely overlap. And yes, we call them congruent circles. Now let's connect congruence with daily life. Look at the ice tray in your refrigerator. Each mold is exactly the same size. Why? Because congruent depressions ensure that every ice cube comes out identical. Or think about changing the refill of your pen. Sometimes the refill doesn't fit, and that's simply because the new one is not congruent to the old one in length and thickness. In industries, especially in casting and molding, congruence is the key. All molds must be identical if you want uniform products. In engineering too, interchangeable parts are possible only because of congruent designs. So, whether it's your pen refill, an ice tray, or industrial tools, congruence is everywhere. Let's explore the idea of congruent figures with something simple: squares. Imagine you pick one square as your reference. Now, if you compare it with a larger square, you'll notice the shape looks identical, but the size is different. That means they are not congruent. Congruence demands both size and shape to match perfectly. Among the given squares, only one matches the reference exactly. That's the congruent partner. The rule is simple. Congruence fails the moment either the size or the shape differs. Here's a quick insight. Congruence is stricter than similarity. It requires an exact match, and that's why it's so powerful in geometry. Whether it's laying identical floor tiles, designing patterns, or cutting puzzle pieces, congruence ensures everything fits together with absolute precision. Hello everyone. Let's step into one of the most important ideas in geometry: triangle congruence. Have you ever cut two identical pieces of paper and placed them on top of each other? If they match exactly in size and shape, they're congruent. Triangles work the same way. Two triangles are said to be congruent when all their corresponding sides and all their corresponding angles are equal. We represent this using the symbol triangle PQR is congruent to triangle ABC. That means side PQ is equal to side AB, QR is equal to BC, and RP is equal to CA. Not just that, but also the angles match. Angle P equals angle A, angle Q equals angle B, and angle R equals angle C. So congruence in triangles is both side to side and angle to angle equality. It's like saying they are twins in geometry. No matter how you flip or rotate them, if all corresponding sides and angles agree, they are congruent. Quick insight: this principle of triangle congruence is a foundation for many proofs in geometry, construction in architecture, and even design in engineering where exact matching is critical. Hello everyone. Let's dig a little deeper into congruence. Imagine you're matching puzzle pieces. Not only must they be identical in shape and size, but you must also align the corners correctly. The same idea applies to triangles in geometry. For two triangles to be congruent, their vertices must correspond in the correct order. For example, if triangle PQR is congruent to triangle ABC, then vertex P corresponds to vertex A, Q to B, and R to C. This ensures that side PQ matches side AB, side QR matches side BC, and side RP matches side CA. But here's a catch. If we write the order wrongly, like saying triangle QRP is congruent to triangle ABC, it's no longer valid. The order of vertices is not just notation, it is the very backbone of writing congruence correctly. So the quick insight to remember is, congruence is not just about equal sides and equal angles, it's also about the exact matching of vertices in the right sequence. Get the order wrong, and the congruence claim collapses. Think of it like reading a password. You can have the right letters, but if the order is wrong, it won't work. Did you know that by just knowing the lengths of a triangle's sides, we can classify its type and even find its angles? Sounds magical, right? Well, that's the power of the cosine rule. Let's take triangle XYZ, where side XY equals 5 centimeters, side YZ equals 6 centimeters, and side ZX equals 7 centimeters. Since all three sides are unequal, we immediately identify it as a scalene triangle. Now, to find the angle at vertex X, we apply the cosine rule. Cosine of angle X equals 5 squared plus 7 squared minus 6 squared divided by 2 times 5 times 7. Simplifying, cosine X equals 25 plus 49 minus 36, all divided by 70, which gives 38 divided by 70, approximately 0.543. Taking the inverse cosine, angle X comes out to about 57 degrees. Since 57 degrees is less than 90 degrees, angle X is acute. Similarly, when we check the other angles, all of them are also less than 90 degrees. Therefore, the triangle is not only scalene but also acute angled. Quick insight, the cosine rule helps us classify triangles by their angles even when only the side lengths are known. Isn't that a neat mathematical shortcut? Let's recap everything we learned about congruence. Congruence means two figures are identical in both shape and size. In real life, we see this in molds, ice trays, pen refills, and machine parts. For triangles, congruence requires equality of all corresponding sides and angles. The correct correspondence of vertices must be maintained, otherwise the statement is incorrect. And finally, we represent it as delta PQR is congruent to delta ABC, written with the congruence symbol. This is the foundation of all triangle theorems and proofs ahead. And in the next session, we'll dive deeper into the rules of congruence, the quick tests that make checking much easier.